I'm Ahmed Dawood, and before the last session, we were discussing the flow, how we can select the best performance measure according to our uh, scenario. So we were reached at that point where we have to now select the best averaging technique. So that's why we have in the last session we have learned what are the averaging technique, how they can be computed, and what are the intuitions behind each average technique, which works where. Okay, so now we will continue our process of selecting best averaging technique. So every technique are three: micro, macro, and weighted. In the case of micro averaging, it actually does not cater with respect to the classes. It follow the way of it give equal weight to each sample. Okay, it don't it does not cater the frequencies of the samples in different classes. So it usually not recommend in the case of imbalanced data set. Now we have just two options, macro and weighted. Okay, so these are the not the ideal solutions. These are just the optimal solutions. Means that there are two average techniques, macro and weighted. Now, first you have selected your performance measure. Uh, let's say if you are curious about the class that I have discussed also in last time, you are curious about the class and you want to highlight the score of that class, okay, in the overall measure. How you can do that? If you have to go towards the class frequency and you have to see what is the frequency of that class in actual data set. IDA class has a high frequency, in the problem with the data set that we are here discussing. Ideal diamonds have more frequency. So if you want to highlight the score of ideal diamond, then you should use weighted. Okay. And in general way, you can say if you are curious about the class which is in majority, you can use weighted average. Okay, but it is mostly you can prefer that also. And if it is the case of let's say if your curious class, let's say here curious class is fair and fair has very less number of samples. Now, if you will use weighted average, due to less frequency of fair class, maybe it's not maybe it's pretty sure that weighted average will give low weight, less weight to that score of fair class, and maybe if your model is bad on that class, weighted average cannot catch that. But if you will use macro average is respective of the distribution of samples in each classes. It give equal weight to each class. It calculate the score for each class, then take an average. So if your class about which you are curious is in minority, have less number of samples compared to other classes, then you can use macro average to highlight the score of that class in overall score. So these are the optimal recommendations, not the ideal recommendations. Maybe it vary upon the your problem statements and your project scenarios. Now we will discuss some scenarios, and according to me, I will say you that performance measure we should use here. First of all, the problem is same here. Imbalanced data set we are having here. Ideal diamonds are in majority compared to all other diamonds, and we also know that from our problem statement, ideal diamonds are more precious, more expensive, and have more importance compared to other diamonds. So let's say you are a seller, and it is mentioned in the problem statement. Let's say if you are seller and you know ideal diamonds are more expensive, and then you will want such type of classifier which should care more about the ideal diamonds. Classifier which should not classify ideal diamonds as some other diamond. Okay, if you are a seller and your classifier will classify ideal diamonds as some fair diamond, and you will sell that fair diamond at the rate of fair. Uh, you will sell that diamond at the rate of fair diamond. Maybe you will lose a lot of revenue. Okay, so in that case, you will be more curious about the that error. Ideal diamond should not be classified as not ideal diamond. Okay, so first you have figure out about which class you are more curious. Then you have figure out how many type of errors can be here. There are two type of errors. Model can classify non-ideal, not ideal as ideal, and model can classify ideal diamonds as not ideal. You have seen that you are more curious about the second error, and you have here selected that if ideal is a let's say ideal is a positive class for a while, then you are curious about the fast selective errors, and it means you are curious about the recall of ideal class. Okay, so you have selected here performance measure as recall. Okay, so now you want such a measure. Now you have you want such type of classifier which should have high recall with respect to ideal class and also good recall with respect to other classes also. For that, you have to take an average of recalls of all the classes. And now here you have to see that you want what type of average you should choose here. There are multiple type of averaging here. Okay, now you will see what how many samples belonging to ID class you have in your actual data set. You have seen that there are a lot of samples belonging to ID class you have here. About majority of samples you are having. So you have selected weighted average. So weighted average recall can be your here best measure, and you know it's also equal to accuracy. And you are getting the point that we are also using accuracy here. Okay, but interpretation is different. Way of selection is different depending upon this scenario. Maybe if you want that your model should be good at the classification of ideal diamonds and also should not be bad on the let's say fair class, then maybe you can go towards the other average. But for now, this scenario, it is coming out that weighted average recall is best here as a performance measure. So second case, let's say now you are a buyer and you know ideal diamonds are more expensive and you will want a classifier which should care more about the ideal diamonds. Means the classifier should not classify some other diamonds as ideal. Okay, let's say if ideal diamond for a while, if ideal is a positive class, and then two type of errors can be here. Ideal, your model will predict not ideal, but actually false. Okay, means your model is predicting ideal as not ideal. That we have seen that seller was more curious about that error. Now, second error can be false positive. Your model is predicting that this diamond is ideal, but actually it was not. Means your model is predicting uh, some premium or fair or good diamonds as a ideal diamonds. Okay, doing false predictions in that way. So you want such a classifier which should care more about the we should cater that error false positive with respect to ideal class. We should have less false positive with respect to ideal class. So for that, you have selected that uh, with respect to false positive, we usually use precision. Precision, which model have high precision regarding to ideal class, will have less false positives with respect to ideal class. Now, you cannot rely on just on the precision of ideal class. You have also to calculate the precisions of other classes. Now, what average technique you should use here? Again, depending upon the frequency, depending upon the your problem statement. Here, ideal has more frequency, In majority, you are using a weighted average. Now your overall performance measure will become here. Optimal performance measure will be weighted average procedure. Okay. In the same way, we can discuss another scenario. Let's say you are a buyer. Again, you are a buyer. Now here you have ideal diamonds 402 and fair diamonds, let's say 5388. Means you are curious about the ID class, and ID class has a minority number or less number of samples compared to other classes, very less number of samples. Okay, and now you are a buyer. You know ID diamond is more expensive and blah blah blah. You want such type of classifier should not classify some other diamonds at ID. We have already discussed. So you know that you are more curious about the precision. You have selected precision as your best score. Now you want that such type of model we should have good precision on the idea class or high precision on the ideal class and also good precisions on the other classes. As precision, ideal class is very less number of samples in the actual data set. Here just 402 samples. So if you will use weighted average can be uh, can cannot catch the bad performance of classifier on the ideal class due to their less frequencies. Okay, weighted average give less importance to the classes which has less uh, frequencies, while on the other hand macro average give equal importance irrespective of their frequencies. So here you can use macro average, so your overall performance measure will be macro average precision. Okay, you got an idea how you can select the best performance measure. Now this is the part of like when you are doing some classification problem. First, you have to select when you are going towards the model building, and then you have to select some optimal model for your problem statement. Then you have to hyper tune your model. You have to select best parameter values for your model. Uh, that's why you need usually performance measure. So first you have to select which performance measure should work in your case. You have selected that performance measure, let's say macro average precision. Now you will select the model which is giving highest macro average precision. Then you will, after selection of model, let's say you have selected logistic regression is giving highest macro average precision. Then you will go towards the part, what are the values of parameters of logistic regression. You will train multiple models, and with different parameter values you will select your model which is with the parameter values having highest macro average precision compared to our other models with different parameter values. In that way you are you also have selected the parameter values for your model. Now you are ready to go. Now you will train your model, and you can again go towards the testing part. Again you can, and you just not rely on that part of accuracy. You again after the selection of parameter value, again you will train your model, again you will test your model, and the process will pass through from multiple iterations. Okay, so this was the overview of how you can select the best performance measure regarding uh, the multi-class classification. Okay, if I will summarize all of that here, first of all, I should summarize it by using the questions that we have uh, risen in the start of that sessions. If I can have here, okay, I should start from here. Okay, and the way of thinking in the case of multi-class classification is different regarding the performance measure because of there are you are having less insights with respect to multi-class classification compared to the binary classification problem. Okay, you are having less insights, so that's why the way of thinking, the way of selecting performance measure in both cases is a little bit different. Okay, although you are using the same performance measures here. Okay, so here first of all, whenever you will have a data set, you have to ask the dataset is balance or imbalance. Balance or imbalance. If your dataset is balanced, no matter problem is binary or multi, you can use accuracy. Okay. Now, if your dataset is imbalanced, then you have to see problem is binary and problem is multi. Now, if the problem is binary, you already have some insights regarding that your majority class is 0, minority class is 1, and everything. Now you have to figure out about which error you are more conscious, and then you can go towards the precision, recall, or F1 score. F1 score if all the errors are equally dangerous for you, or you can say if all the classes are equally important for you. Okay. In case of multi-class, in case of multi-class, you first have to figure out because you have not insights regarding multi-class which class have more frequency. So first you have to figure out the error or error about which you are more curious. You have to first figure out about which class you are more curious. After that, you have to find about which error you are more curious. If I will write here in that way, okay, about which error you are more curious. Then you have to select, if I will make here just two. Okay, then you have to select the best performance measure according to your situation, precision, recall. Then you have to select the average, okay, averaging technique. So you have selected your precision and recall. Now you have to uh, from this query class, you have to see its frequency in actual data set. Frequency. Depending upon its frequency, you will have two options. If frequency that your class about which you are curious is in majority is have lot of number samples, a lot of samples, and it is falling in among the classes, among the upper classes which has high number of frequencies. So then it means lot of samples here. And if it is among the classes which has less number of samples, less number of samples. Okay, so now here you will use macro average, and here you can use sorry, weighted average. Okay, and you got an idea how you can select the best performance measure. These are the optimal way of selection of performance measure in case of multi-class. And if you are curious about let's say if you are saying all classes are equally important for you in multi-class case, you have dataset imbalance, your dataset is imbalance, and you are having multi-class problem, and you are saying that all classes are equally important, or you are saying that all classes are you all classes yeah, or all errors are equally dangerous for you, you can use F1 score because all errors are equally dangerous for you, and all classes are equally important for you, macro average for that part. Okay, so you can also use macro average F1 score if all the classes of equal importance in case of multi-class classification. Okay, so I hope you got an idea about this section of performance measure in multi-class case. A lot of intuitions in that scenario, and keep in mind always there is no one solution. There can be a multiple solution. You should find optimal solution according to your problem statement. Okay, there are also we have discussed Matthew's correlation coefficient in the last session of binary classification, and it was having the we have discussed its difference with F1 score. So Mike Matthews have the main advantage over the F1 score that no matter about which class you are labeling as a one, MCC can calculate the score. Okay, best score. But F1 always work good in that way if you are having more majority samples are labeled as 0 and minority samples are labeled as 1, because it is asymmetric in case of binary, and while MCC was symmetric. Okay, it was asymmetric, and both work in the way when when you have imbalanced data set and all classes are equally important. Okay, so now you can ask here why we can use here MCC. Okay, in case of multi-class, can we use? You can ask. Okay, the main advantage in the case of MCC was that it's a formalized design in that way. It is catering all the cells: true negatives, false negatives, true positives, false positives. But here you also have seen in case of average multi-class classification, we at the end, after taking calculating the score for each class, we are again taking the average, and in that way we are also let's say if you are having in that way number of classes. Okay, so actually in the case of precision, in the case of recall, you are covering catering all the cells of your confusion matrix in the case of recall in that way, in the case of puzzle in horizontal vertically also, and in the case of F1 score, both in both ways you are catering. Okay, okay, so the main advantage that MCC score was having over the F1 score in the case of binary classification was that MCC catering all the cells and F1 was not catering. But in the case of multi-class classification, you have seen F1 score is also catering all the cells of confusion matrix. Okay, so here you can also just rely on F1 score. Uh, in a lot of sources, a lot of sites, you will see that some people are using MCC also for multiple classification, and maybe it was working good. But here I will not discuss that MCC. Okay, because we can fulfill our need by F1 score also. Okay, second, there are also some people are using other techniques. If I will tell you here, like I have discussed in the last binary performance barrier regarding binary classification, there is also a technique people was or people usually are using for classification problem. Cohen's kappa coefficient. It's actually statistical method. Matthews is also statistical method. So people are also using that, and I am not again going to in the detail of that because it has interpretation is a little bit different, and I hope you can cover all of that we have discussed there. Okay, people are also using cross entropy. Okay, again cross entropy can use evaluate the classifier also for the multi-class classification. But again, I usually not recommend cross entropy. Okay, because cross entropy cater the probabilities of the with respect to each class, but there can be a chance that it can dodge you, or there can be some classifier which has some good probabilities, but can be have some uh, le- uh, bad predictions or less good predictions as compared to other classifier which has better predictions, but regarding probability, it is having a little bit lesser probabilities compared to other classifiers. So that type of case can occur if you are using a cross entropy. Okay, although people are using that also. Also, there is a measure uh, like I have discussed before. Also, average area under ROC curve. Okay, people are also using that after calculate ROC area under ROC curve for let's say with respect to each class, let's say ideal class in the way idea by constructing the confusion matrix. Let's say if you have 4 by 4 confusion matrix, you can construct 4 different confusion matrix. Understand? You are getting my point. 4 different confusion matrix, and in that way, or if you are using the technique OVR, one versus rest, which is also giving the probabilities. and in that way they are calculating the area under ROC curve for each binary classifier, then take an average. But again, people are using, but I usually not recommend that also, because here there is no concept of threshold, and it can also do you. Okay, because there is no concept, and you also have seen that in the case of multi-classification, we are not getting our predictions on the basis of threshold. We are getting our prediction on the basis of highest probability, which class having or which classifier. Okay, if we are using a technique in which multiple binding classifiers, then which classifier is giving highest probability, the class of that classifier consider as a prediction. In case of multi-class classification, which class have good or high probability compared to other classes considered as a prediction. There is no concept of threshold setting here. So that's why I also not recommend average ROC, cross entropy, Cohen's kappa, and Matthew. That's why I am discussing here. People are using a lot of in a lot of articles. You will see that people are using MCC, Cohen's kappa, cross entropy, average area under ROC. Okay, so you should play them. I am not saying that you should not go towards that side. You should play with these type of measures, and best in the field of data science, the best scenario is that you should use the optimal solution with respect to your problem statement. You don't have to use some fancy formulas or fancy or such type of measure that all everyone is using that you should use. It's not the way. Maybe are facing some different problem. Okay, so there are a lot of measures available. You should study these type of measures. You should focus on them. You should learn their intuitions, so that you can understand in which case scenario this can work better. Okay, there are different formulas here. You should know about them so that you can get an understanding. Either you have to use them or you have to use some other measure. Okay, so Matthews correlation coefficient, Kahn's kappa, cross entropy, average. You will see some other measures also, but for now you should consider that I have discussed uh, in this flow chart. You can follow that pattern. Okay, and keep in mind, also in data science, some as I told you, so a lot of formulas and their intuitions, but usually we don't towards the side how the formula is generated. Okay, we go towards the side what are the use cases of the formula, how the performance or this formula, this technique actually works, what is the intuition, what can be results we can generate from that performance measure, from that technique, so that we can apply in some practical field. Okay, we are not here doing some research regarding how they were originated, what is the history of that measure. We are not going in that way. We should have some intuitions, some understanding regarding their working of these techniques. Okay, so I think it's a lot of advices in that session. So if you are getting bored, sorry for that. But for now, it's enough. In the next session, we will do a code. It will be quite simple. Everything is easy, just for you to keep yourself familiar and in touch with the code. I will do coding session in the next session. So for now, thank you.